You know, for the longest time, we've thought of our solar system as this perfect, orderly machine, a kind of cosmic clock, all sealed off from the rest of the galaxy. But what if that's not the case at all? What if our quiet little neighborhood actually has an open door policy, where cosmic wanderers are passing through all the time, and sometimes they even decide to stay?
So let's just get right to it with one simple question. Is our solar system really an isolated island in the vast ocean of the Milky Way? I mean, we tend to think so, right? We've got our sun, our 8 planets, all locked in this predictable dance that's been going on for billions of years. But some really recent discoveries are forcing us to completely rethink that cozy little picture.
And you know, for centuries, that idea of a cosmic clockwork seemed to fit perfectly. But then, in 2017, we got a visitor. Its name was ʻOumuamua. And just 2 years later, another one, 2I Borisov, came flying through. Now, these weren't your average asteroids or comets. Oh no, they were confirmed travelers from other star systems. Their flybys were absolute proof that cosmic traffic is real, and that our solar system isn't some closed-off system. It's more like a dynamic crossroads. Now, we're not just talking about little bits of rock here. Some of these visitors could be enormous. And that brings us to a major player in this whole story, the rogue planet. These are basically planets that got kicked out of their own home systems, and now they just wander through space completely untethered to any star. And get this, they aren't rare. Astronomers think there could be trillions of them. Trillions! Just in our galaxy. So if the galaxy is just swarming with these lonely planets, it begs an incredible question, right? Could our sun actually capture one? Could it add a whole new world to our solar family? Well, it turns out the answer is yes, and some fascinating new research shows us exactly how it could happen. So how in the world does our solar system adopt a cosmic orphan? Well, it's this incredibly delicate gravitational dance. First, a rogue planet drifts just close enough to feel our sun's pull. As the sun reels it in, the planet picks up a ton of speed. Now, normally, it would just whip around the sun and shoot right back out into deep space. But, and this is the amazing counterintuitive part, the gentle but constant pull of the entire Milky Way galaxy acts as a kind of cosmic brake. It's this stabilizing tug that slows the object down just enough for it to get trapped in a stable, permanent orbit. And look, this isn't just some wild guess. As the lead researcher Edward Belbruno explains, it's this combination of forces, our sun's powerful local pull and the galaxy's subtle background tug, that's the secret sauce. It creates a mechanism for a permanent capture, turning a complete stranger into a brand new member of the solar system. Okay, so this whole idea of capturing planets naturally leads to a much bigger question, a more personal one. If our sun can snag rogue planets out of the void, is it possible it's happened before? I mean, could our own home, planet Earth, have started its life as a lonely wanderer before being adopted by our sun? All right, let's play detective here. What would we expect to see if Earth were a captured rogue? Well, for starters, it would probably have a really weird, stretched out orbit, and it would likely be tilted at some random angle compared to all the other planets. It'd probably be way out in the boonies, far from the sun, and its chemical makeup would be different from its neighbors. But Earth? Yeah, it fails on every single point. Our orbit is nearly a perfect circle. We're lined up neatly on the same flat plane as everyone else. We're pretty close to the sun, and we share the same basic chemistry as our rocky neighbors. The conclusion is pretty clear. All signs point to Earth being a homegrown native, not a cosmic visitor. Whew, all right, so Earth is a homegrown planet. But remember that open door policy? It swings both ways. And this is where things get a little scary. This is the other side of the coin. If objects can be pulled in, can a planet, like, say, Earth, be kicked out? This is where things get chaotic, and I mean that literally. Imagine our solar system is this really stable, predictable dance between the sun and its planets. But then, a massive new dancer, a passing star, crashes the party. The whole choreography gets thrown into total chaos. That's the core of what's known as the three-body problem. Those stable orbits can become wildly unpredictable, and the stability we've relied on for billions of years could just unravel.
So what are the odds? Well, researchers ran simulations for what would happen if a star passed within 100 astronomical units. That's just a little more than twice the distance to Pluto. What they found is that in 92% of those cases, all 8 planets actually survive on stable orbits. But in the other 8% of cases, the system gets seriously disrupted. At least one planet gets lost or its orbit gets dangerously scrambled. The odds are in our favor, sure, but the risk? It's definitely not zero.
And if we happen to fall into that unlucky 8%, what happens to us? Well, the most likely scenarios are, frankly, terrifying. We could get flung directly into the sun, or we could get sent on a collision course with Venus, or even our own moon. There's even a small chance we could be ejected entirely, doomed to become a cold, dark, lifeless rogue planet ourselves.
And look, don't think for a second this is all just theory. This stuff has happened before, and it's absolutely going to happen again. Let's pull up the galactic traffic report, because our cosmic street can get pretty busy.
If we look back in time, we can see this isn't new. About 2.8 million years ago, a star called HD 7977 made a pretty close pass. And much more recently, just 70,000 years ago, a binary star system known as Schultz's star skimmed the very edge of our Oort cloud. But the really big one, that's still on its way. In about 1.3 million years, a star named Gliese 710 is set for a dangerously close flyby. How close are we talking? About 10,635 astronomical units. Now, that might sound like a huge number, but let me put it in perspective for you. Our Oort cloud, that giant sphere of comets way out at the edge of our system, it extends out to 50,000 AU or even more. So yeah, Gliese 710 is going to plow deep inside that boundary. It could potentially unleash a massive storm of comets right into the inner solar system. So when you put it all together, the possibility of capturing new planets, the threat of getting kicked out by passing stars, you get a totally new picture of our home. It's not some impenetrable fortress. It's more like a fragile oasis, constantly interacting with the galaxy around it, being shaped by forces from both inside and out. And just to be clear, these close encounters aren't some once-in-a-billion-year kind of thing. Not even close. On average, a star passes within 50,000 AU of us, that's inside our Oort cloud, about every million years. And a much closer pass, within 10,000 AU, like the one Gliese 710 is going to make, that happens roughly every 20 million years. This is just a regular part of our long, long journey around the galaxy. So what's the big takeaway from all this? It's that our solar system has this secret history, you know? There could be captured worlds orbiting our sun right now on these distant, chaotic paths that we haven't even detected yet. As Edward Bell Bruno puts it, we're just beginning to uncover the secrets of the objects that might have joined our cosmic family over billions of years. Which brings us to one last, pretty sobering thought. For 4.5 billion years, our solar system has navigated this cosmic traffic, surviving every close call and somehow maintaining the delicate stability that allowed life to flourish right here. We've been really, really lucky. But now we know the cosmic highway is always busy. The real question is, how long can our luck possibly hold out?